Hi there, this is Dr. Embody with Project 3. This project is actually a lot like Project 2. We have a loop. We're going to have just do a calculation, in this case your tuition. There are a large number of cases, many more cases than we had in Project 2. But just a bunch of if-else's, and then we also throw in some while loops for error checking, like if you try to input a negative number of credits, you got to keep going until you have a positive number of credits, things like that. When I made this recording, we've got we have this flat tuition, block tuition that we have, and there are some fees and so on. The university provides a calculator, so we're just writing we're basically writing that. This won't be exactly right. There are some things that I left out because, well, we already had enough loops and conditional statements in there. And then also when I transferred some values from the official sheet into the one for the project, I messed up some of those numbers. So work off the values in the project rather than what some of the official ones are, and of course semester to semester some of those values will change also. So let's take a look at it. Here's the official page off the university. This is the one for residents in fall of 2019, and we will actually have residents as well as non-residents, and then you have each particular class that you're in, and because we have block tuition, 1 through 11 credits, it's done per credit. Then 12 to 18, everybody gets the same, and then when it's bigger, you take the flat rate and then the per credits that are greater than or equal to 19. So this goes up to 18, so if we had 20 credits, that's actually 2 more credits than the 18. So you'd take the flat rate plus 2 times the per credit rate in order to do that calculation. And of course, now things get messed up a little bit. If you're in the business college, you have these values are different. The engineering college, these values look like maybe they'd be different, but in fact they're the same. Why they did it out this way, I don't know. Probably what's on the other pages. Some of these values I just didn't leave in there because we already had enough if statements and so on in there. But there are fees that come into play here, and there are ones for the juniors and seniors depending on which college you're in. And then whether you're part-time or not, which is 4 credits. The engineering is based upon admitted rather than junior and senior. And then we have some taxes, and this is where I copied some of the numbers over wrong. So we use the ones in the, we won't actually use these values, but in any case, so there's a tax on all undergrads. There's a tax on all degree students for the FM radio. James Madison has their own fee, and State News has its own fee. So there's a lot of complexity in there. And what I've done is I've taken this table and copied it into the project. Now we do have a few differences here, so I combined it into one table. You can see we've got resident as well as non-resident and international, but everything else is pretty much copied over. I did combine these two into one column because they were in fact the same. We've got these fees, and we pick up the international one here, and as I mentioned, some of these values I didn't copy across exactly right. Use the ones in the project specification. For testing purposes, we have to we have to do things in a particular order. So we ask for the resident, and if they're not resident, then we ask for international. Notice that there is, the prompts that you have are dependent upon some of the previous answers. There is a level, and we do some error correcting here in that if one of these strings is not entered exactly right, we will keep asking until you get one of those right. So we get a little loop in there. And then we ask for the college and CMSE and engineering and the James Madison, and there are notice that there are if statements here, so we don't always ask these, we ask them conditionally. And then finally credits, and with credits we will be asking for those until you give us a valid integer, so we'll loop through that. And then there are some other things, like for example, these yes/no questions. We specify that if it's yes, it's yes. If it's anything else, it's no. Similarly here, when we ask for the college, if you give us some bogus values, the college will be none. That is, none of these particular four. As with the previous project, you really need to do these by hand to get them right. Before I go to that, let me point out in particular number 7 here. You will be tempted to say an expression like this: if the level is equal to freshman or sophomore or junior or senior. That doesn't work the way you might want to, because we learn that non-empty string is true, so this is really level equals freshman or true or true or true, and that will always evaluate the true no matter what it is. So you actually have to, in fact, do it out long: level equals freshman, or level equals sophomore, or level equals junior. Very common type of mistake to make. Make sure you don't do that. And then here we specify all the rules that I mentioned above in terms of the error correcting. So let's take a look at a particular case. Like, let's take test 1. And let's do that out. Let me get the real numbers away, and we'll bring in our table here, and let's go through a particular calculation. So we ask these things. So we have a resident, we have a freshman, not admitted to the College of Engineering, not in James Madison. We've got 12 credits, so let's go and check this out. So resident, all right, so we'll be on this side of the values here. We do have a freshman. It's and so it's not admitted to the College of Engineering. We are at 12 credits. So that puts us in this box. All right, so our base is 7,230. Okay, so none of these apply, and these always apply. We have 6 or more credits, so this one will apply, but we are not James Madison, so that one will not apply. These amount to $29 of fees. And by hand, we see that we match that. So now I know that by hand I'm doing my calculations correctly. Let's take another one. The test 2. Okay. So it's a resident, we have a junior, and so because it's a junior, we ask for the college. We've said business. Are you CMSE? The answer is no. We have 17 credits. All right, so now we're still in the resident side of things here. Now we're a junior, but we're in the business college, so that puts us here, and we are at 17 credits, so that would be this one here. And so our base amount, 8595. And let's see, so now we have a business and junior. We aren't part-time, so we've got $226 to add on here. We check all of these because we have 6 or more credits. We are not in here, and so again, that gives us $29 more. So we come up with 8850. It matches that. So now, so if I go through these cases, and probably ought to check your own tuition, you can now have confidence that you're understanding how this project works. Now, one of the things about this is that, well, we run our tests. That is the basis for the scoring. But in fact, we don't test every single possibility, but your program must be correct for every single possibility in order to get full credit on that. And then if you were to build in something like said what we mean by hard coding, it's like, oh, if the credits is 17, then the tuition, I'll just create the tuition as $8,850 and it just ignore the rest of the inputs. We call that hard coding, and then we would just give you 0 for the project. All right, so I'm not going to talk anymore about the coding itself, but what I would like to do is comment a little bit more on using the debugger. So I wrote a piece of code here that looks a little bit like what what your code will look like. Not much, but a little bit like it in that you might want to define some constants. You don't have to. You'll have some kind of a loop, like a while loop. And I did it with, I used done here, and then at the bottom I prompt, do you want to do it again? And I threw in a tertiary thing here, which you can look up if you'd like. Kind of a cute way to do that. And I initialized some variables here. And there's a bunch of if statements and else statements and else ifs and so on. And then finally at the bottom we print a value. You're going to have something that looks like this, except it's going to be a lot longer, a lot longer. So let's take a look at this code. And so I double click there and put a breakpoint. I will, just for to clear out values, I'm going to set this up so that I don't have any of my old values kicking around here. And let's start this thing in the debugger, and remembering that when we're working in the debugger, this is the one that starts me off. This is the one that steps one instruction at a time, and this one is a stop. So we've got step and start. So we've got the start, and these other ones we'll worry about. These two in particular deal with functions, so we don't want to use those yet. This one will just take you to the end, and this one stops. So we have a start, a step, and a stop there. And I set this breakpoint by double-clicking on it. I can undo it also by double-clicking on it. All right, so let's start this. And right away, the program runs when I start it until it hits the breakpoint. And so you could see here that this is slightly highlighted. It might be a little hard to see in the video. And I can now start stepping through the program. And if I look in here, so I have my constants A, B, C, D, E. They all have a value of 5. I just wanted to put something up there. My done here had a value of false. Okay, I've done the T, so that has a value of 0. And as I step through here, okay, we ask for an L, and let's see, I've got some things like C's and D's, so let's give it a C. And you see that here I have a C for L, and I just keep going along, and now many of my variables now have values, and of course I'm using terrible variables, but that was on purpose for this. So here are the variables that I'm using. We've got a C, which has a value of 15. We've got done, which has a value of false. We've got L. We entered a C for that. S has a value of none at this point, and T has a value of 0. And X is a Boolean, and that has a value of true. So we've got all of these here, and we can see their values. Okay, so and this thing is highlighted here that we're at this point where we actually make a decision. And since my L has a value of C, we expect to go in there, and then we're going to ask for a C here, whatever that is. Let's give it a value of X. And so now we see that my S, which started with a none, now has become a string, and we move on. X has a value of true, so I'll go in here. My C has a value of 15, so we now expect that because C has a value of 15, this is false, so we expect to go down here to the else. And so when I do the next statement, we did go into the else, and then my L has a doesn't have a value of B, so we skip past that. My S has a value of X, so we will expect to go in here. And here is the line where I'm going to do my calculation. And so when you're checking your code out and you're getting an incorrect value, you have two things to think about. Did I get to the right equation? So, by hand, you should know which equation you should be working with. So it's, did I get to that? And then the question is if I've got the wrong value, then if I got to the right line and I'm getting the wrong value, then that means my equation or my calculation on this line must be wrong. But one of the other nice thing that's here is that after I do this line, notice that my T in this case now has a value of 75. So I've done that calculation. I know right now that I have a value of 75, and I was able to see that I did the calculation on this particular line here. So you can now ask yourself, is that the correct line that I'm supposed to be at in terms of my logic? And hopefully you'll have things not single letters, so you'll be able to make some sense out of how you got there. So you're really looking at the right line and to the right calculation. All right. This is what the debugger helps you with. Did I get to the right line? And if so, do I have the right calculation there? And then after that I can we'll go down here to the print statement, but it doesn't actually print within the debugger, and then it will ask me do I want to do it again, and if I put anything in there, then it will bounce me out of that, and now my done is true. We can see here my done is true, and the program will end. If you're curious about this funky looking line down here, what is it saying? It's saying done will have the value of true if my R is not equal to yes. So if I don't give it a yes, done will be true, and I will be done with my loop. If this equation is not true, then my done will be assigned to have a value of false. So this is something, if you look at that and that makes sense to you from a readability standpoint, feel free to use it. If you don't like it, then write out an if-else statement, and we'd be perfectly happy with it. Hopefully that helps you a little bit out for how the program works and a little bit on the debugger.